The world had come to a standstill. Everyone was confined to their homes during lockdown 1.0 in India. Retail stores, restaurants, theaters, your favorite chaat wala bhaiya, everything was shut down to prevent the spread of COVID-19. However, one could still see men and women on their scooters zipping through the deserted streets in black and orange uniforms. They were saddled with a black bag and sported a large S on the front. Superman? They truly are. Despite the pandemic, the delivery partners of Swiggy made sure food from our favorite restaurants was delivered to us in the safe comforts of our home. Due to the service, restaurants could continue to function. This helped cap their losses and keep their customers full. However, the health of the hunger saviors was at risk. So, certain safety measures like always wearing a good standardized mask were put into place, protecting both the delivery partner and the customer. Simple fix, right? Except there was no way of knowing if the measures were being complied with or not. As the delivery partners zoomed all over the country, it was the headquarters' job to make sure they did so safely. So first, they had to identify and unmask the right problems and add it to the menu. For starters, the problem was being able to identify if a person is wearing a mask or not. The second course of action was being able to identify if the mask worn is standardized and meeting all the protocols or not. The last course was to build an automated system that could be implemented on ground. Swiggy runs a large-scale operation that spans the entire country. So how did they pull it off logistically? Upon wondering how they can help their delivery partners and ensure their safety during this pandemic, the Swiggy team came up with an idea of utilizing computer vision to detect masks in real time. In other words, it is an algorithm that helps the computer channel its inner mom vision. You know, the kind that can locate the socks you spent 6 hours looking for in about 3 seconds? Moms just somehow know exactly where to look. Anyway, it is a classical problem that data scientists deal with, which is to train the computer to know exactly where to look to find the desired object. First, the system has to be able to detect the face of the delivery partner and check if they are wearing a mask or not. The system should also be able to detect if the picture is irrelevant selfie or a random background and reject it. The next feature they thought of was one that checked the quality of the mask, that is, whether the mask is of good quality, substandard, or simply a fancy handkerchief. Now, the only plausible solution to it would be to lock everyone inside a house like Big Boss and do a manual check, right? Well, it might have worked for one location, but how would they do this for all the places across India? It would be a logistical nightmare. So how did they pull it off? Well, the answer to this lies in data. The right data in the right quantity, along with a lot of training, would be able to solve this issue. Now that the team knew what they had to make, the next step was to collect the right ingredients in form of data. Swiggy figured out that the partner restaurants could help in collecting that. So, what they did was they asked the partner restaurants to take pictures of the delivery partners when they came in to collect the orders. It was done as a part of an on-ground mask compliance evaluation. Through this exercise, about 3,700 pictures were collected, but that was nowhere near enough to deliver a complete dish. So, readily available dataset from RMFD or Real World Masked Face dataset was used, bringing the tally to about 10,000 pictures. The first dataset was now ready. But before they started training the model, there was one more step. The pictures had to be annotated. That means the machine had to be introduced to what a face without a mask looks like and what a face with a mask looks like. To teach the machine, pictures of delivery partners that were already stored in the Swiggy system were manually segregated and annotated by the team at Swiggy. This way, the machine had its basic concepts in place before attempting the real test, being able to identify faces with and without masks all by itself. It is easy for us to identify things because we have a built-in scanning system in the form of our eyes. But that is not the case with computers. So how do they see and identify? The answer to that in short is CNN. No, not the news channel. That is not the computer's source of information. Rather, CNN here stands for Convolutional Neural Network, a type of algorithm. I know the word convolution itself means complex and twisted, but we will try and simplify it so you don't have to worry too much. Now, tell me, what did you see? I saw a face while my friend saw a little girl sitting under the tree with her back facing us. We both looked at the same picture. Why did we see different things? This usually happens because of light receptors in our eyes. I perceived these dark shapes as a nose and eyes, and these curves as a face, while my friend perceived it as a little girl's hair. A convolutional neural network does something similar, except there's some math involved and the architecture has multiple layers. In computer vision, every image is broken down into pixels, kind of like a color by number. As you can see, each shape in the picture has been assigned a number, and you can color it accordingly to make a beautiful picture. CNNs reverse this process. They take a fully colored and completed image and break down each part into a square or a pixel. Each pixel is then assigned a number between 0 and 255 depending on how light or dark that particular pixel point in the image is. This calculation of light and dark is done by considering three primary colors, more commonly known as RGB or red, green and blue. The computer now has a matrix of numbers, kind of like a bingo board, which it can use to determine certain shapes in the picture. Much like our eyes perceive an optical illusion, that is, by making sense of certain shapes, lines and colors, the edge and the curves of the object in the image are perceived by mapping the outlines created by difference in pixel intensity. At each layer of the neural network, more information is added on top of the information from the previous layer, like a game of Chinese whispers, and in the end, instead of a confused sentence, we get a complete image as the computer is able to distinguish certain defined shapes like eyes or paws and then map that back to a larger object like a face or a dog. The CNN that Swiggy uses is called retina face and FPN or feature pyramid networks. They are basically CNN algorithms that are capable of a higher degree of task complexity. Now that they had figured out the system, it was ready to hit the road. Your order is on the way. The mask detection feature was launched on the app. It was initially a way for the delivery partners to show that they are wearing masks and are being safe. The mask compliance checks were rolled out successfully across the length and breadth of India. Of course, this is no mean feat. Swiggy relies upon the smartphones of the partners themselves to ensure mask compliance. How did they make sure the system wasn't duped, you ask? Well, they trusted the delivery partners to always do the right thing. I am kidding. We know everyone doesn't always do the right thing. To ensure that the delivery partner is wearing a mask, they were required to take and upload a selfie before and after each delivery. When a delivery partner reaches a delivery location, they had to take a selfie till the chest. That is, before they hand the food over to the customer. After the food is handed over, the delivery partner has to enter the PIN given by the customer and take a selfie again to show that they are still wearing the mask. Unless these steps were followed, the app would not allow the delivery partner to proceed and complete the order. Thus, delivery partners had no choice but to follow these safety measures, ensuring their health as well as the customer's health. Wrong orders, missing items in the orders? The rollout went smoothly and the mask compliance feature was serving its purpose well. However, it wasn't a perfect system and there was room for error. Soon certain glitches in the system began to show up. The RMFT dataset that was used to train the system mostly had pictures of East Asians. As their skin tone was much lighter than that of the Indian, the system was refusing to recognize delivery partners with a darker skin tone. To fix this problem, the system was trained based on the photos that the delivery partners took while delivering the food. By making sure every delivery partner took selfies before and after deliveries, the engineering team was building the ground truth dataset by collecting and adding selfies taken by the entire ground force across all times and cities. This dataset was used by the system to better itself. Then a second and more pressing glitch was discovered. The system was recognizing a hand covering the mouth as a mask. This is what is called a false positive. By holding their palm over their mouth, delivery partners were able to beat the machine, turning the compliance check features redundant. The feature had a high accuracy rate of about 80 to 90%, which means it was able to distinguish between a masked and an unmasked face pretty well by now. Then why was it reading a hand as a mask? That was because the object detection algorithm was based on object occlusion. Simply put, the algorithm first noticed the eyes of the person, then checked for their nose and mouth. As long as it did not find the nose and mouth because something was blocking, it would detect it as a mask. So the system had to be trained to recognize masks more precisely. To recognize good quality masks from scarves and handkerchiefs, it was necessary to feed the system with hundreds of images in every type of mask and its alternates in order to train it. This was time consuming and the engineers were working against the clock. So instead of providing the system with what is, they provided it with what isn't. They simulated a set of synthetic images by editing different types of masks onto faces of their delivery partners and another set with hands edited onto the faces of the delivery partners. Through a process called registration, these synthetic images help detection model to understand the difference between a hand obstructing the mouth and a mask obstructing the mouth. Eventually, with the help of a library software like TensorFlow, more efficient object detection modules were incorporated like efficient det. Even as we speak, more hiccups are being weeded out with the help of data science process. The more data in the form of pictures at different times of day, in different weathers and cities is collected, the better it is to train the algorithm, providing higher accuracy and precision. Although the mask compliance feature began as a way to encourage the delivery partners to wear masks, Swiggy's goal is to expand its usability to ensure compliance of other company policies. Temperature checks, wearing the right gear like the Swiggy t-shirt and bag, wearing a helmet while traveling between deliveries can all be checked with help of this seemingly simple feature on an app. Well, my name is Sachin Manji. I have over 18 years of experience in the industry. My expertise is in machine learning and big data analytics. And today, let's deep dive and see how Swiggy solved this problem using data science.